All right, hello and welcome. So I'm really dying to know, how many of you have come here because this is a Jedi analytics session and the only one on the agenda? Okay, and how many have come here because you really want to know what the personal crisis was? Okay, that's what I was really hoping for. So this is now my 13th Tableau conference doing presentations, and one thing I've learned from the previous 12 is that if I name the session what it's actually about, at the end people are like, oh hey, I just came to your session because the one I wanted to go to was full, and actually this was the thing I really needed to know. So I figured I should just stop naming my sessions what they're about, and yeah. This way you'll come in the room and hopefully I'll teach you something that is more interesting than my personal crisis. I'll tell you in a moment what that was, but first let me just start by talking about the objectives of the session today. So one of the things that a lot of Tableau users say to me all the time is like, how do I become really, really good at Tableau? And my answer is always, that shouldn't be your goal. Your goal, that should be like a sub-bullet point in your goal. Because operating the interface is really a minor part of being good at Tableau. What's really important is to understand, like, how do you apply Tableau to solving problems, like end-to-end scenarios, and then even beyond that is like, how do you generalize the data that you're working with right now to like more abstract principles and concepts. And once you can do that, all the problems start to look the same, and suddenly you are a master of your craft. And I'll give you an example of that. So this morning we had someone from a bank come into Tableau Doctor, and they were working with this problem, looking at buying and selling different currencies and trying to figure out like what's the balance of their currencies that they're trading. And everyone's sitting there looking at it, and I was like, this is a flow problem. Just do this one thing, and now you're good. And then they were off, and they were set, and they could solve the problem. So a lot of the times it's like recognizing the abstraction of like, what is the semantics that you're trying to represent? Once you know that, you can set up the problem, and then solving it is actually easy. So the other thing I've learned from my previous 12 conferences is I used to always try and teach like everything I know in 1 hour, and that doesn't really work. And in fact, I think you can really only like consume knowledge of like how to operate a tool, but once you get into these like deeper, less visible levels, rather than just consuming other people's knowledge through like training videos and so on, you really need to like create your own knowledge by experimenting and drawing connections between different things. And so you become your own teacher. And so my goal is really to just inspire you all to develop more expertise in Tableau analytics or whatever it is really that you want to be a master at. There's a few meta points to this as well. This is not the core of the session, but yeah, just some other points that will come out of this. So one is how this applies to optimizing performance. Raise your hand if you have run into performance problems with your workbooks before. Yeah, so it's basically the biggest challenge, and you'll see why. The second is like, what should you be doing to progress your career? Maybe not, but an idea. Who here is like responsible for building teams or hiring people? Okay, cool. So there's some stuff in here for you as well. And then who here is responsible for making recommendations to your organization on what software you should be buying? Okay, cool. So there's some stuff in here for you too. And I promise it's not just buy Tableau. There's like a broader application to that statement. All right. So now I'm going to go into the actual story of what was the personal crisis. So raise your hand if you are not a citizen of the country in which you live. Yeah? Okay, me neither. So I live in this country for the last 7 years, but I'm a Canadian citizen. And so just in February of this year, I reached the point where I'm now able to apply for permanent residency. Before that, my immigration status was tied to my job at Tableau, which meant if I do something bad, I get kicked out of the country. If I lose my job, I get kicked out of the country. So that's always a nervous position to be in, especially with all the alcohol that you have at parties like Tableau, just day and night out. Okay, so one of the things you have to do for this application is show how many days you've been abroad in the last 5 years preceding your application. And you're required to be in the UK for 180 days of every one of those 5 years preceding your application. And I was like, yeah, this is totally no problem at all. And so I booked my appointment and paid the thousands of pounds and then submitted the expense and was reimbursed by Tableau and thought everything's great. And then maybe it wasn't, which you will see in a moment. So let's go and show what happened. So it was January 7th, 2018, when I began collecting the data from that really, high-tech format in which we capture passport stamp data today, right? So no choice but to manually convert every single stamp into a, let me open it up here, into a data set like this. So this was Saturday was creating this amazing data source by capturing every single stamp in the passport. And then, what was it like re-entry into the UK? Was it arriving into France? Was it departing France? What was the purpose of the trip? And so on. Okay, so I thought it was just a really simple case of, I'll just quickly calculate this. It will take 5 minutes and then be done. So here's what I did. Oh, it's disconnected. Oh, I think what? Help. This happens every time. I never learn. I don't want to touch anything. I just banged the thing and it all went away. All right. Yay! You're the hero of the show. Okay. So now I've connected to this data source, and so I have a date field on like what day was the stamp, and then I've got the trip. So if I want to know the duration of days abroad, I need to know the start and end date of every trip, and then just calculate the duration. Simple, right? Okay, so we know who's familiar with level detail expressions. Okay, good. So basically, I just want to find the minimum date per trip. That'll give me the start date, and then the maximum date per trip. That'll give the end date. So we express that in a level of detail syntax by saying fixed to the trip, the minimum date, and this is going to be my start date. Okay, cool, easy. Then just duplicate that, take the maximum date per trip, so just change the min to a max, and then this is going to be the end date. Oh, and I'm going to, that's good, actually. Yeah, okay. So now the duration is going to be just end minus start. So just drag in the end minus the start, and then I'm going to add 1 so that it counts both the edge days as being days abroad as well. So this is now the duration abroad. And so, cool. Now it's in this whole data set. I've had a busy time in the last few years, 746 days abroad. And then split it up by year. And oh my God, 2014, 189 days abroad. And so then I started to completely freak out that 9 more days abroad. That was the year that we were building the France. Do we have any French partners here? Yeah, okay, nice. That was the year of like building the kind of partner ecosystem in France, so I was there all the time. And now I thought, okay, if this is really true, I can't apply for residency for another like 2 more years, and that's like 6 more conferences of data night out that I have to survive without losing my job. No, just kidding. Kind of. And so, this is really bad. So then I noticed something. So it was January 7th that I made this viz. Does anybody notice something that might be suspicious? 11 days, yeah. Like, how is it possible to be abroad 11 days when it's only the 7th day of January? So I went into the underlying data and noticed that what's happening. So this trip started on the 23rd of December of 2017 and then ended on the 2nd of January. So it was actually only 2 days out in 2018. but then like 9 days out in 2017, which means the trip duration is 11 days in total. And so it's allocating the entire duration of the trip to that one, to both years essentially. Let me show you more specifically. So if I filter to that trip, 118, it now shows that it's counting 11 days in both years. So it's double counting those number of days. So this was the first time I was like, I am so happy that the data is wrong. This is amazing. Normally you spend all your time trying to get the right numbers. Go to Jonathan Drummy's session, he'll tell you how. Yeah, so it's wrong. So now I started to think, okay, actually, yeah, there's a point to this. I'm going to leave the suspense hanging for a while and just use this as a teaching moment. So I'm going to show you how probably 99% of people would try to solve this problem. And I've seen it happen before, and it results in some very sad moments. So let's say it here. So most people will look at this and say, okay, here's all my trips. I can see that this trip here, for example, spans 2 years. It's 20 days in total, and so I somehow need to allocate those days correctly within each year. So the obvious way to solve this is we have a calculated field dialog, and so that seems like the obvious way to solve this. So the first thing I'm going to try and do is figure out what are the rules required to be able to split and allocate these days across multiple years. So the first thing I would think is I only need to do this kind of splitting allocation for trips that span multiple years. So step one would be identify which trips span multiple years. Okay, let me do that. So trips across many years is going to be, you can find that by saying if you fix to the trip level the count distinct of years of the date, and if that's greater than 1, then you know that it spans many years. And so that's exactly what's happening here. So it's highlighted this one here that's spanning 2012, 2013. Okay, so now I have my kind of condition, and so now I need to figure out how to actually allocate the time. So in this case here, I basically wanted to take the 17th of December up to the 30th of December, count the amount of time in that interval, and then allocate that to 2011. In this case here, I want to take the amount of time between the 1st of January up to the 5th of January, count that time, and then allocate that to 2012. So that's kind of conceptually what it's doing. So now you express that in Tableau kind of syntax, and you get something like this. So if the trip spans many years, then I'm going to leave that, else give the duration, we know that thing is right, end. Okay, so I've set up my calc. Now I need to do my kind of sub-condition here. So if the trip is across many years, then I have another condition which says if the date is equal to the start date, then I want to count, so as a date diff, the number of days in between the actual date, and then I'm going to make a date which will give me, which I want to be the December 31st of that year, so just take the year of the date, and then make your month 12, and then make your day 31. And then otherwise, you want to say if it's the end date, so if the date is equal to the final date of the trip, then you want to do, what is it, the date diff from, on the day level, I have a spelling error here, one moment, let me fix this. On the day level between, now I want to make the date to be January 1st of that year, so then it's going to be the year of the date, and then 01, and then 01, so that's January 1st, and then compare that to the actual date of the passport stamp, and then if it's not that, I just want it to not count anything for the middle ones, and then end that condition, whoops, and then this should maybe give me my time allocation, or something, right? Fun. Okay, so let's see what happens. If I bring this into here now, so it's got, oh wait, yeah, it's 14 and 4, it's adding up to 18. I forgot to add the boundary dates. So let me go and add that. And now you just like incrementally fix it. So let's do +1, and then let's do +1, and now I'm going to just like inspect. Okay, so it's right now for when the trip spans many years, but now it's wrong for when it doesn't span many years. It's like, looks like it's double counting. So then if you say, what's the number of records? Bring this in. There's 2 records, so this duration is multiplying this duration by the number of records. There's some like replication happening. Why are there many records there? Let's bring the data to the most granular level. And so if I do this, it's because there's departure, entry, and arrival. So there's multiple directions associated to my trip. So now I need to maybe just have one direction, return the value for just one single direction. If you're like, wow, my head is spinning, just remember that this is what you shouldn't be doing. Okay, so now it's like, I'm going to add this other condition that says, otherwise, if the direction is equal to the entry, then give the duration. Okay, now if I do that, okay, so now it's not double counting. It's just giving the right numbers. I think I have the right numbers. Let me go and then build my viz. And so do that, and then that, and then that, and then that. And now it's 173. Like, maybe this is right. So if it is right, it means it should add up to the big 746 days. So let me just verify that. But no, it adds up to 757. So therefore, I know this is wrong. It's still doing some level of double counting. So now I'm going to like go and incrementally see if I can fix this. So I suspect probably the issue is in the trips that are across many years. So I'll try to drill down on that. And then I'll look at the trip ID. And then I'll say, well, what about the different directions again? What's happening there? And then if I bring in the date, can I start to see where the problems are? Yes, okay. So now I can see that there's, for example, this trip here where I think this was a stopover in Iceland or something. We went to the Blue Lagoon. Very nice, highly recommend it. Yes, it was a stopover in Iceland on the way home from Canada at Christmas. And so now it's counting this time allocation 3 times because there was arrival, departure, and entry like all on one day. So now I have to figure out how do I account for that. So maybe then we'll say, I have this sequence field. So maybe instead of looking at the trip start date and the trip end date, instead what I will do is look at the maximum sequence value for that case. So I'm going to go back and now incrementally modify this and say, instead of comparing the date to the end date, I'm going to say if the sequence is equal to, let's see, the maximum sequence for that particular trip. Okay, maximum sequence. Boom. Okay, and then I only have 1, so maybe this is okay. Let's go back and see what happens now if I look by this. And then if we add the running total, it's 746. Okay, so I know that the data is probably right now, and it's 173, so yay for me. That means maybe I can stay, except there's a twist, which I will tell you later. Okay, so the point is, who's like, that was the worst thing I have ever seen on a conference stage ever? Raise your hand. It's terrible, right? And this is like what people get into all the time. It's just like, I don't really know what I'm doing, so I will just like react all the time. And oh, I see this error, so now I will account for that case as well. And you'll notice like this actually doesn't, it's actually wrong if I get new data in, because now I've fixed my, where is the thing? I have fixed my, I fixed the end date for the sequence, but the start date using the start time. Well, that condition is also possible for the start time. And so a lot of people, without thinking about like the semantics of the thing they're trying to express, they just hard code their calcs against the data that they have, which means you're maybe not accounting for edge cases that could occur in new data. And so then you get, well, I guess if we were software engineers, you would call that bugs. In this case, you get wrong data. So it's very, it's complicated to do this. and it also risks giving you really wrong results, and it also results in like really borked data that doesn't make sense. So if I wanted to look at like, which countries was I in at this time, it doesn't even make any sense. These big bars here are the UK, except I'm looking at trips abroad. And so that's not even possible. And so, yeah, because I've just like fixed this to solve that exact problem, it now doesn't actually merge back with the rest of the data to enable follow-on questions. So, okay, the twist is, then I went and read the small print within the UK Border Agency application, and they don't define the last 5 years in terms of calendar years. It's rolling years relative to your application date. And so now, how do I modify this thing, right? Like, I've hard-coded this to the 12th of the 31st. So this thing is not built in a way that's like general and easy to extend. It's just hard-coded. So now I would have to go and rebuild this from scratch to actually get the right data. Okay, so now I'm going to show you the way I actually did this. And I only learned to do it this way by spending a lot of time doing that, I will say. Okay, so let's go back to the slides. So if instead of thinking about like, this is the exact result that I need against this exact data that I have, if you instead kind of step back and think like, okay, I'm working with data about time. What do I know about time? And you approach it from this much more conceptual level, then you might do something very, very different. So let's just start with some basic terminology. So a moment is this isn't necessarily the absolute truth. This is just my definition for the purpose of this presentation. Let's say a moment is a point in universal time. A period is a universal time segment defined by 2 moments, right? You might also call that an interval. And a duration is then the length of a period. So these are just some basic terminology that we can think of when we're working with time data. Okay, now you have many, many, many different types of temporal tables. So the one type of temporal table is an event table. So in an event table, every record represents a state change at a moment in time. So really common case of that would be support cases. When you file a support case to Tableau, it's like the case has been submitted, and then status changes to like awaiting like triage of a rep, and then it changes to whatever, like so on. A state table. In a state table, each record, so every row in the table, represents the state of that item. So a case, for example. In the case of my passport, it's me, right? It's a state during a specific period of time. Then you have a calendar table. And so this is a dense time range. By dense, I mean like the intervals are equally spaced, and you have a value for, if it's at a day level, you have a value for every single day. So it's a dense time range, and the bounds of that time range are determined by the domain in your event table. And then you have another type of table is a timetable. And so it sounds similar to an event table, but it's not. In the timetable, every single record represents the state at a moment in time, right? So the event table is a state change, whereas the timetable is like, what is your state at that point in time? Meaning your state could be the same across many points in time. And I'm going to show you I'm going to apply this to the data, so it's not so abstract. But in general, here's like 4 types of ways of representing time data. So here's an example. So the event table is the one I was just working with. So at a given point in time, or like a moment, a property of an entity changes to a new value. So in this case, the entity is the passport holder. You could have many. In my data set, I just have me. The time is the date of the passport stamp. And so in this case, the time is representing a moment. You get the passport stamp at a moment in time. I'm also defining the direction here as a moment. When you enter, the entry is then over, right? It's an instantaneous action. And arriving, you have now arrived. You cannot continuously arrive, That would defy physics. And then the country is a property, visa is a property, and so these properties change. Like the country I'm in changes, the visa eventually changed to a tier 2, that was a glorious day, and so on. So then what does a state table look like? In the state table, I'm looking at a duration, like a period, which is defined by a start date and an end date. And so yeah, during that period, the entity has a specific value for each of these given properties. So in this case, the entity is me. Then there's the start and end date of that particular segment. So in this case, I'm not looking at trips. I'm actually looking at segments or like journeys of a trip. And then, yeah, again, the properties are changing values. So that part is the same as the event table. Then a calendar table, it really only has one single column. And so this table is just a dense time range. So you'll see here I have a value for every single day. And it begins, that was the date I first moved to the UK, the 21st of September. And then it continues all the way until like the present. And then the fourth type of table is a time table. And so here I'm saying for a dense range of time, a property of an entity has a specific value. So in this case, you'll see that I've now replicated this, like my state is I am studying in the UK from the 21st of September, and then it just continues. That gets copied down all the way till December. And then there's basically a record for every single day saying, where are you and like what is your state of being at that time? So 4 different ways of representing time. So which of these representations do I need to answer the question, how many days abroad was I per year? That one, exactly, that's right. So that's a question where I need to have a record for every single day to count the days abroad. So how do you create a timetable? So here's how these tables relate to each other. So the state can be directly derived from the event table. It's basically just, kind of take instead of having a single time range, a single date range, you need to look up the date for the prior state, or the date for the next state, and that will give you your end date and start date interval. So that's just a direct derivation. The calendar table is like an independent table. It's just a dense time range. I should probably have a dotted line back to the event table because it's bounded by the events, but then everything is dense in between. And then a timetable is derived by joining the state and the calendar table. So now that we have a more kind of conceptual basis for how do you analyze time data, now let me show you a different way of approaching this problem than just brute force, incremental iteration that just gets you sucked into a giant hole of technical debt. Okay, so we can do this now using Tableau Prep. Who's used Tableau Prep before? Yay! Tableau Prep is great. So let me connect to this passport stamps data. And bring this in. Okay, and then I'll add a step. And okay, so now I have multiple records per trip. One for like the arrival in the new country, departure from that country, and then the re-entry into the UK. I really only need a single record. Actually, no, I'll do that at a later stage. So yeah, the first thing I need to do is, instead of having my data in event form, I need to turn it into a state form. So the way to turn it into a state form is to have a period which is defined by a start and end date. So let me do that first, and so let me remove this and instead add an aggregate. Actually, wait, sorry, nope, let me do, see, prep is so easy you don't have to memorize your steps. And so I'm going to just duplicate the date, so let's call this date 2. Okay, so now with that, I can add an aggregate. So in the Tableau desktop with LOD expressions, right, the equivalent of LOD expressions in prep is essentially aggregate and then join back. So I'm basically saying group by trip the minimum and maximum date. So I'll bring these two fields here and say, this one will be a minimum, this one will be a maximum. So this is now my trip start, and then this will be my trip end. Okay, and so then I can join that back to my passport data like so. It's joined it on trip ID. So awesome, I have that now. And let me add a step. So I've got trip start, trip end. I no longer need this date field. I'm going to just remove all the stuff basically that I don't need. Probably want to keep that. I'll just remove these things. Remove those. Remove that. And yeah, wait, remove. Is there any, did I need to join it back? I don't know. Yeah, actually it's fine. Okay. Yeah, that's probably okay. And let's just keep one of those. Okay. So now, and I can hide that now that it only has one value. So now I have a state table, which you can see here. There's like for every trip, there's the trip start and then the trip end. So that'll tell you like what's your days abroad. And so now I need to join that to a calendar table. So I'll bring in this calendar table, and then here I'm going to use an inequality join. So if I bring this into this join here, now I want to say, it's not matched on anything, but I want to say keep the calendar date when it is, I want the trip start date to be less than or equal to the calendar date. And then I want another one here that says the, trip end date is going to be greater or equal to the calendar date. And so now, when I look at this data here, actually let's add a step and view it that way. And so now you can see that for this specific trip here, it's now generating a record for every single day abroad, essentially. So now if I go and open this in desktop, so now if I look at the number of records and then split that up by the year of the calendar date, woohoo, it's still 173. And you can also double check, there's 746 records in this data source. So the thing that was, what's interesting about this is, where's my original one? So the thing that was the, in the events data, the duration that I derived through LODs, that was 746 records. The time allocation as well, that like insane calc, was also 746 records. But now this Maestro output has 746 records. So like you can get to the same number in like all of these different ways. So yeah, I know that it's right, and now I can be like gloriously victorious. Oh no, I haven't yet calculated my rolling year. I can't be victorious yet. So let me go and create my appointment date parameter. And so the appointment date that I had booked at this point was, where was it? It was the 6th of February, 2018. Okay, so now I need to create this like kind of rolling year bin. So let me go ahead and make that. So here I just need to, it doesn't work when you rename your things. This was the calendar. Okay, so this is basically just looking at the difference in time between every single day and then the appointment date, and then dividing that by 365, taking the integer component, and that creates a nice rolling year calculation. So when I then save this, you'll see, just to show you what it does. So when you look at the year here, and if I do this as a bar, you'll see that it's saying, 0 years back is including like 2018 and most of 2017. 1 year back is including a bit of 2017 and all of 2016. So it's now anchoring that from like February to February. So now, this is the moment of truth, 176 days. Oh, and I wouldn't hit the thing. What was the button to push? I haven't learned yet how to, oh. There's just, pardon me? Yeah, yes, it's true, and not 2,000 people. Yeah, okay, there, 176 days. So yeah, just by 4 shy days. So what I really should have called this session is not how Tableau helped me solve a personal crisis, but how Tableau made me realize I should be in a personal crisis. Isn't that great? And how Tableau made me realize I didn't make the wrong decision. Okay, so my next question at this point was, well, that's really lucky, like, and also it's really insane that government policy states that like the date of your appointment date can influence whether it gets accepted or rejected. So then I started wondering, like, well, when, is there cases when it would have been rejected? So if I look at, you know, the 17th of March, it's 178 days. So if I'd applied in March, I would have really been cutting it close. And so you start to wonder, like, what about, 179? Like, on which days would it have failed? And so who here ever wants to do what-if analysis or some kind of scenario analysis? Yes, okay. So this is basically scenario analysis. What if my appointment date was on this other day? Well, you can sit here. I'm going to use this as a teaching moment again and just leave you hanging on the 179. But yeah, so instead of having to click through the parameter and see what would have happened on this day or on this day or on this day, that's very manual and just not very optimized. It would be much better to just say, well, here's the time range over which I want to apply that scenario. Show me, like, when would it have passed and when would it have failed? And so back to our theory. This is, oh, right, let me just summarize before I go into that. Yeah, so just to summarize here, the last example. So we discussed those 4 types of tables, and now you've seen an example of every one of those types of tables. So you have the passport stamps, first of all, was an event-based table showing the change in state. Then the one we just created now, so trips with begin and end dates, that's a state table, or that was an intermediate step of the Maestro flow. We created a state table. Then the time range between the calendar, that kind of Excel file, that's a timetable. And then the days abroad, which is the output from the Maestro flow that joined to the state table and the calendar table, created a timetable. So you've now seen an example of every single one of those types of tables. And so then the next thing, where is it? Hold on, I put my slides in the wrong order, so that's fine. Nope, yeah, there's a 5th type of temporal table. So there's event, state, calendar, time, but there's this 5th type, which is a scenario table. So in a scenario table, every single record represents a moment in time for which you wish to analyze the state of the universe. So in my case, what would have been the state of my application for every single one of these appointment dates? Yeah? Pardon me? You mean of the rolling year count? Yeah, I think I know. It's true. I just assumed the UK government wouldn't account for them either. Pardon me? For leap years. Then I would have figured out how to do it. So that, yeah, I think that's a problem where you'd probably, so one of the things I did actually look at is like bank holidays, and the way I solve that problem is create a kind of calendar table of these are all the bank holidays, join that, and then wherever the result is null, you know that it was a working day. So I imagine with leap years you'd do probably something similar. Yeah, if you have to do that, we can have a look in the after. So good question though, good observation. Okay, so now we have these 5 types of tables. So the question is, like, how do these relate together? So we saw state can be derived from event. State joined with calendar gives you a timetable. If you join a timetable with a scenario table, then you get to be able to do multi-scenario analysis in a single view. So that is what we will do now. And so I can go back to my Tableau Prep flow here and just modify this one more time by bringing in this appointment dates table. So this is this appointment dates table here. If I just add a step and you can see it, is, again, it's just a list of all appointment dates from the 2nd of February 2018 to the 2nd of February 2019. So to join this to my data, I need to do so before, for the calendar table, we did an inequality join in order to bound that table between the start and end date of the trip. In this case, we want to do a Cartesian join. So that means like replicate my timetable for every single appointment date record. And so the way that you can do this type of Cartesian join is by just joining on a column that has the same value for every record in the table. So let's do this by, by adding a calculation. Why is there no calculated field? Let me try this again. Add a step, create a calculated field. So I'm going to just call this join, make it equal to 1. You can make it equal to anything. It just has to be the same value. And then I can do the same thing here, create a calculated field, and then call this, make this also equal to 1. And now I can join these two tables on 1 is equal to 1. And so now when we look at our output, what's my resulting table? It's done lots of stuff. So let's go and look at this in Tableau. Okay. So now you're going to see that this thing has 272,000 records. And what it's done is for every appointment date, it's replicated those 746 days abroad. And so now I can take that rolling year calculation and then see for every single one, so like every point on that line is essentially an appointment date. It's a scenario. So calculate the rolling year relative to every single one of those points. So I can actually take the exact same calculation that does not account for leap years, and that, well, I spelled very differently, so I'm going to look at calendar here and appointment dates here. So now, before, I had taken the difference between the date and that single value appointment date parameter. Now I'm saying take the difference between the calendar and this like multi-value field. And so this now gives you the rolling year. And so before I put this on the viz, let's add a reference line. Where is it? For 180 days. Okay, and now split that by the rolling year. And bada-boom! It would have failed if I applied between mid-March and all the way up to August. So my application at this moment in time, especially in July, would have been the worst ever. So I was just really lucky, and now I have what-if analysis, multi-scenario analysis in Tableau to show me that I'm incredibly lucky. Okay, and let me just show you, because again, this is kind of a weird viz to look at. A lot of people are like, what is it showing? Because it's not actually showing trends over time. So back here, let me show you what it's actually doing. You can think of so when I take this appointment date parameter, let's set it to, what day is it today? It's like July 5th. So if I set it to today, the line chart is essentially showing you every single cross-section of that date is equivalent to the bar chart. So you'll see here, this 192 is equal 192, 141, 141. So the line chart is basically this bar chart, just for every single appointment date. So that's a nice way to do multi-value scenario analysis. So is this useful for people? Yay, okay, cool. So let's just go back now to the slides and summarize. And let me go and move back the ones. Nope, that one was Never move your slides right before the presentation. Okay, so one thing I want to point out is that when we did this allocation calculation, it didn't actually map to a real world concept, right? So if I make this big so you can see it, like you could not describe what is a record in this table. It's just nothing. It's just I borked the data to get the right numbers. Whereas when we were looking at this approach of like describing tables in terms of events or state or calendars or time or scenarios, your data source always represents, it always maps back to a concept in the real world. And so that is effectively the difference between sort of simplicity versus complexity. So like complexity arises from like incrementally and reactively solving a problem, which is a really natural tendency. Whereas simplicity requires a clear understanding of two things. The first is what the data actually represents. So if somebody asks you, like, what is a record in your data source, and you can't answer that question, that will be the origin of a massive amount of complexity. So always have that be your first question. And those of you who I saw in Tableau Doctor, like you'll come and a lot of people will come and be like, here's this calculation. And I'm like, no, shut it down. Tell me what a record is in your data source. And then we'll worry about that. And then the second is like the semantics of your question. In my case, did the question relate to events, or did it relate to days, or did it relate to an interval, or so on? In the case of that doctor question I described at the beginning, it was relating to flow. What do I know about flow? So figure out those two things. And once you know that, then it just becomes a technical problem of like, how do I map this data to the semantics of my question? And then that's just a technical problem of how to operate the tool. If you're missing those 2 points, but you know how to let me be clear, that first example I showed with allocating the calcs requires an enormous amount of technical skill to actually get there. But yeah, you need a lot more than just technical skill in operating the tool set to get to the to get to good outcomes. So now let's talk about, I promised you there were going to be a whole bunch of meta points. There were 4 meta points. So one was about how does this relate to performance optimization? How does this relate to progressing your career, building teams and hiring people, and then finally making software recommendations for your organization? So let's talk about optimizing perf. Now performance problems in like the vast majority of cases are the result of complexity, right? And complexity results from a lack of, in many cases, a lack of conceptual understanding about what you are doing. And a lot of people will always ask, is there a decision tree that we can follow for how do we optimize performance? Or they'll look for these like hard and fast rules, like don't use count distinct, or context filters are bad. These are some things I've heard customers say, is it true that context filters are bad? It's like, it depends. Probably not. It's almost never that simple, right? And so like be highly like mistrusting of like these absolutes. And so the way to address performance is really like think holistically and just understand what you're doing. Think about like what are the semantics of the problem you're trying to express. Ooh, that's really loud. Now there's like there's something about this there's something very conflicting about this though, because what's amazing about Tableau is that it permits iteration and discovery, and you don't necessarily know where you're going. So how can you start out with this approach of like holistic thinking and systems design if you're just exploring and you have no idea where it's going to lead? And so that's where this point comes in. Like break things into stages and kind of like be aware of like what stage am I in right now? If you like iterate and discover and explore, and then you might arrive at like, okay, this is the final result I want, and then go into stage 2 and rebuild it from scratch once you know what you want. So be prepared to call your V1 baby ugly. And like a lot of people are not willing to do this, so they'll create monstrous calcs like the one I showed you at the beginning in some cases, they'll spend like 6 months doing it, and they become like emotionally attached, right? You have to be ready to call your own baby ugly and just throw it away and start from scratch. They're like, the numbers are right, just make it fast. I'm like, I can't without starting over. The performance is like so intrinsically linked to the design. So yeah, emotional detachment, just be resilient. Okay, so what does this mean for progressing your career? Now, you've probably heard Tableau talk a lot about how performance, it depends on the design of your workbook, right? We have Alan Eldridge wrote like a 90-page white paper on this. Now, I'm going to distinguish that into two types of design. There's visual design, and then there's data design. And those are just vastly different skill sets. And so ideally, be awesome at both. But in particular, I would say there's a massive, massive shortage of really good data designers. There's lots of people who are really competent at using Tableau, but not at designing the data in a way that makes it perform. So I will just say, like, companies are willing to pay a lot of money for this. If I didn't find like Tableau so interesting, I would totally go do that. So yeah, focus, like, if you're like, what should I do? What skills should I acquire? Become good at that. And so then how does this relate to building teams and hiring people? So I think it's really awesome that Tableau enables people to, who are not like necessarily, haven't got this background in architecture and so on, to be able to do lots of things, right? You can operate the tool with relatively limited skills, which is great, and that's great if you're sharing your workbooks with a small group of people. That gets really conflicted when you're doing things like deploying content that has SLAs. So if you're creating like client-facing apps and you're charging your clients a lot of money for these apps, or you're like doing embedded analytics and you're embedding your dashboards inside of operational applications that are accessed by like thousands of people, or if you're creating executive dashboards, like basically any kind of like high visibility, high SLA content, then like that needs a completely different skill set than just I'm building this dashboard to share with my immediate team. And so I will reiterate, visual design and data design are very different skills. And so you may need two people for one job. It's actually like quite rare to find people who are great at both of these. And again, a lot of the, I'm on the side where we hear all the complaints about performance, and a lot of them come down to, we hired this person who's amazing at visual design and like understanding business requirements, and then put them in charge of deploying this solution to thousands of people. Maybe have both, so you can have them prototype and figure out what should be in the dashboard, and then have a second person to just rebuild it from scratch when you know what you're going to present. I think that would solve a lot of like our kind of highest priority perf problems. And the final is making software recommendations for your organization. So everything that I've shown here is like very non-specific to Tableau. This whole principle of like, I don't really know what I'm doing, so I'm just gonna like take incremental steps and react to like the immediate feedback. If you build software in that way, it ends up being really bad. Surprise. And so a lot of companies they look at like two things when they're evaluating software. They look at features and they look at price. And if you're in this room right now, you're probably sold on Tableau. And you might be like battling within your organization of like, why should we pay for this thing when there are free tools that do the same thing? I know I've had a lot of interactions with people who are like, I know why it's great, but I can't tell my boss. So when you only look at features and price, you end up, with software that's built in the same spirit as the first example, right? So it's super complex. It's slow, it's incompatible. Do you remember I dragged out country, and it's incompatible. So that's what happens, is that these companies will just like, oh, this customer asked for this feature, we'll bolt that on, but it doesn't work with any of the other features. Because it was built in this incremental way. You also end up with like, when you build software like that, there's like this curve of like exponential time required for every new feature added. Because you recall how I was like, oh, I forgot to account for this case. let me add that in. In software engineering, now you have to account for the previous 100 features you built as edge cases. It creates like beasts and monsters, and that's why they're free. And so one of the most important criteria for determining the utility of software is actually, do the features compose well? And I will be amazed one day when a company files an RFP that says, show us that your software is composable. Composability, like language is highly composable. I can reuse the same words in many sentences. And so this means that like whoever's building the software needs to like deeply understand what they're building. And that's essentially where Tableau came from, right? It came out of a PhD thesis that broke down visualizations into language-like components, which is why it's so highly composable, and you can build, it's not a wizard-based, these are the 4 charts that you can have, but you can compose all of the color and size and so on to create anything. And so I would just say software originating from academia is much more likely to have this. You guys all saw Clive Benford yesterday up on stage. So I've known Clive for like 5 years now. And we had this conversation, like he mentioned that they're using RapidMiner at Jaguar Land Rover. And the reason that they chose RapidMiner is because it also originated from a PhD thesis from Ingo. I've met him. He's amazing. Anyway, so yeah, it was just quite interesting to see that there are companies who are starting to think about that in making their software recommendations. So that kind of concludes my talk. Hopefully it was entertaining and hopefully there was something in it for everyone. And so please fill out the session feedback in the app and questions. We have about 5 minutes for questions.
So does the document software, did that calculate it?
So I was actually amazed. I submitted a paper Word document and they just looked at it and were like, okay, this is probably right. Wow, amazing.
Thanks. Sorry.
Yeah.
With that data set, so actually that will answer a big problem that I've got, which is with HR data in terms of getting attrition, and you need like a start date and an end date.
Yeah.
But we've got like 4,500 employees. So what am I going to get from a scalability if I like start trying to run a timetable chart for every one of my employees for the 20 years, 30 years that they might have been working there?
Yeah, so you'll probably end up with a data set that has like 500,000 records, which is still not big.
It'll be well beyond that. Because if it was for every day...
Wait, 4,000 employees. I mean, it might be in the millions, but it won't be like Tableau's data engine will scale to hundreds of millions, billions in some cases. So that data, like HR data, won't get into that.
So it's still going to be a good performance point. Okay.
Yeah.
Great.
Yes.
Would it be possible, if it did get too big for Tableau, would it be then possible to aggregate it back down to what you needed? Would that break it conceptually to try and do that?
I mean, you can start to look at, if it gets too big to run queries against live, you can do the aggregation in Tableau Prep, so it pre-computes it. And then it's not computing it as the user's waiting for a response. Any other questions? Yeah?
Thank you. Very interesting and personal experience. I had something related, and the issue with the Cartesian product becoming very large. Is there a way with Tableau Prep to run through the parameters one by one? Once you're done with one, aggregate the results of the calculation you're looking for. In that case, what would be the max time abroad for the year? And then you return only that to Tableau in a case where the Cartesian product would be too large to handle.
I think that's exactly what Tableau Prep does. Is you can start out with a really big data set and then aggregate it in the flow, and then your resulting output is much smaller. I might have misunderstood the question.
When you did the Cartesian product,
when you do the Cartesian
and you return the whole thing,
yes.
Can you aggregate that even if the Cartesian product would be too large? Is there a way to cut it into small pieces, one parameter at a time, aggregate the results of the calculation you want.
Yeah, so in my case, I pre-aggregated before applying the Cartesian product. So instead of, because before I had many records per trip, so I removed that, kind of aggregated down to just have one record per trip, and then apply the Cartesian product. Whereas if I applied the Cartesian product to the raw passport stamp data, it would have been 3 times larger, so it would have been like 600,000 records. So it depends on what you're trying to do, but yeah, you can, you should be able to kind of pre-aggregate and then add the Cartesian product. It's all going to depend on the scenario.
Yeah, thanks.
Any other questions? Yeah.
Given that HR, leavers and joiners
Yeah.
problem is such a common one, do you think that would be a sort of standard plug-in feature at some point, just to be able to tell you on a day-by-day basis how many people you employed?
So I can't answer that directly, but I can tell you that I gave the same presentation to a group of researchers at Tableau, and I presented it in a very different light than I've just presented it to you, and they were interested. That's all I can tell you. And there may or may not be working builds of... Yeah, are we good?
Yeah.
Is it
Yeah.
time? Yeah, okay. Thank you very much for attending, and if you have any further questions, yeah, please come up.